Hello and welcome. This is a continuation of my video series on embedded C. In my last video, I explored the subject of C functions. In this video, I'm going to look into the subject of pointers and find out how pointers and C functions are related. But first, let's look into memory and variables and find out how they are related and how in turn they are related to pointers. Now before we go any further, let me just remind ourselves of the original 8051. Here's the block diagram of the 8051. And in particular, I like to focus on the memory portion. And in the original 8051, there are only 128 bytes of RAM. And you may have on some variant 8K of ROM. But I am more interested in the 8089S52, which is the variant of the original 8051. And for the 8089S52, it has 256 bytes of data memory and 8K of code memory. Memory organization. The microcontroller or microprocessor memory consists of millions of bits of information. These are here in this diagram, they're represented here, bits of information. It could be a 1 or a 0. Now these bits, collectively, they're organized as a group, and each group that is 8 bits or a byte is known as a memory location. Now each memory location has an address, and usually in a microcontroller or microprocessor system, memory locations are usually given a hex value. Now for the data memory, there are only 256 bytes in total. So the address is only an 8-bit address. Here it starts off with 00 hexa. That's 8 bits or 1 byte. And then it moves up to 01 hexa and stretches all the way up to FE hexa and FF hexa. That's the maximum address we have for a 256 bytes of memory. Code memory. The code memory of the 8089S52 consists of 8K bytes, and each location, the address, is a 16-bit address. So at the bottom of the code memory, the address would be 0000 hexa and stretches all the way up to 1FFF hexa. Variable. A variable will be allocated a location in memory at the time of compilation. Now, to help us understand how this is accomplished, I'm going to use the following code to demonstrate it. So I've uploaded the demonstration code here, and I've compiled it. I'm getting 0 errors and 0 warnings. So let's go to the debug session. Alright, and I have set up the watch window to monitor data 1 and data 2. And I've also set up a memory watch window here. So, okay, before we go ahead and single step the code, let me just draw your attention to the disassembly version of this source code here. So char data 1 assigned 05 hexa, that's been translated. Let me zoom in here. Okay, all right. So data 1 has been allocated a memory location 08 in data memory. So 08, location 08 is being assigned or allocated to data 1. And the data that I want as assigned to data 1 is now going to be stored in location 08. All right, let's zoom out. All right, so let's go ahead and single step this one and watch out for the variable here at the right hand corner. So single step and zoom in, and you find in data 1 it's been assigned 05. And let's go to the memory location. And you see at the location 08 we have 05. All right. Let's zoom out and let's execute or step through the next instruction that would assign 0A55 hexa to data 2. Right. So now 0A55 hexa is allocated to data 2. Before we zoom into this part, let's zoom in at the disassembly part of the code. Right, okay. Here we go. So data 2 has been declared as an int data type. And the int data type is a 16-bit data type, so it requires 2 locations. So the compiler has allocated location 09 and location 0A to data 2. And the data that are assigned to data 2 is being split up into 2 parts, 1 byte. So 0A is being copied into location 09. That's okay. And then 05, hexa 05 is copied into location 0A. All right, so let's zoom out and let's now zoom in here. And you find data 2 has been allocated 0A55. It's been assigned to data 2. All right, so let's check out the memory. And you find in location 09 and 0A. So in location 009 we have 0A. Location 0A we have 55. All right, so that's how the compiler allocates the memory location to the variables. Pointers. Before we define what a pointer is, let's do a quick recap of what is a variable. A variable is a value which can change during the execution of a program. Here I have an example of a variable called index. Is of the data type int for integer, and I've assigned the the decimal value 6 to index. Now this value here could change during the execution of program. the program might add 1 to this, subtract 1 from this value, and so on. So a variable is a value that can change during the execution of a program depending what the purpose of the program is. So now, what is a pointer? A pointer is a variable that stores the address of a variable. Declaring a pointer. Right, I have a code fragment here, and the first line here, int asterisk pointer variable 1, and the second line, int data 1. Now the asterisk pointer variable 1 is a pointer variable, and the data 1 is a normal variable. The asterisk here tells the compiler that the pointer variable, which is pointer variable 1, will be used to store an address and not a value. The int, which stands for integer, indicates that the address will point to an integer variable. Now, how do we assign addresses to the pointers? So I've repeated the earlier 2 lines of code, and here I allocate or assign decimal 5 to data 1. And here for pointer variable 1, I have assigned the address of data 1 to pointer variable 1. And to do that, I need to fix this ampersand sign to the variable name. Let's take a closer look at this. All right. So the ampersand sign, which is this symbol here, is the address operator, and it is used to get the address of data 1. So here, by putting an ampersand sign next to data 1, we are saying that we assign the address of data 1 to pointer variable 1. And one thing to take note is pointer variable 1, which is this one here, is the pointer and not the one with the asterisk. Let's look at the demonstration code. Okay, so let's take a look at the demonstration code. Let's start off with line 5. Line 5 I have int and then asterisk pointer variable 1. Now I'm using the asterisk here as an operator to declare that this variable pointer variable 1 as a pointer variable. Right? So now you need to be aware of the way this is written. I have seen code that is written with the asterisk with a space between the asterisk and the variable name. Or sometimes I've seen it written with the asterisk next to the data type. Now, my own personal preference is have the asterisk in front of the variable name. All right, so any of the ways that I pointed out to you is valid. So it's up to you. But I've chosen to have the asterisk operator in front of the variable name. So now pointer variable 1 is the pointer variable. Now the next line I like to look at is the line 7. I have declare data 1 of the type int, integer. What that means is this data type is of 16 bits, so I allocate a 2-byte data to data 1. I have assigned 0305 hexa to data 1. Now, next line that I'd like to point out is this pointer variable 1 assigned with the address of data 1. The address of data 1. How do I know this is the address? This is because of the ampersand sign in front of the variable name. So what that means is this is an address operator that tells the compiler that we need to assign the address of data 1 to variable 1 and not this value here. Okay, so let us now compile the code. We have 0 error, 0 warning. Let's go to the debug session. Now, I'd like to point out to you this part here, the watch window. I'm setting up a watch for to monitor pointer variable 1 and data 1. At the moment, it's all zeros because we have not done anything yet. And now, okay, before we do anything else, also let's look at the disassembly code. And let's zoom in here. Right. Notice that this int data1 0305 is being translated into its machine code here. And I'd like to draw your attention to these two hex values here. This is 0B, 0C. These are addresses of memory location being assigned to data 1. So data 1 will have addresses of 0B and 0C. And notice here is the actual data that I have assigned to data 1. 03 is stored in 0B, and 05 is stored in 0C. Right? Let's repeat that. 05 is stored in location 0C. All right. Let's move a little bit further down, and the pointer variable 1. Wait a minute. Let me zoom in. Pointer variable 1 assign ampersand data 1. It's been translated into its machine code here, and I like to highlight these three locations. Pointer variable 1 with the Kyle IDE compiler, it assigns 3 bytes of memory location to its pointer variables. Kyle, I think Kyle IDE quite generic pointers, and that's how things are done with Kyle. So 3 memory location, location 08, location 09, location 08 is being assigned to pointer variable 1. And this, just to draw your attention here, 0B, all right, is stored in location 08. Why is that important? Because if you look at here, this is the address, starting address of data 1. All right. Okay, we'll come to this a little bit more detail in a few moments. So let's come out of that zoom. All right, so let's single step line 7. So I'm going to, in my code here, I say assign 0305 hexa to data 1. And we need to watch data 1 here in the watch window. So single step using F11, and then let's zoom in the watch window, and we have data 1, and we see 0305 as expected. All right. So, and let's look at the memory location 0B and 0C. Why 0B and 0C? Just a quick reminder. 0B and 0C, location 0B and location 0C is assigned to data 1 here. So it'd be good if we just have a look at those memory location, and you will see that I set it up here. So let's zoom in. Yep. 0B, 0C. And we'll find 0305. Okay, so that's that part. Let's go back to the watch window. Now let's step through line 9. Line number 9 here, we have pointer variable 1 assigned with the address of data 1. Okay, before we step to the code, let's remind ourselves briefly. In pointer variable 1 is allocated location 08, location 09, and location 08. So that's the addresses are allocated to pointer variable 1. So bear that in mind. And right now, if we to look at the watch window, currently it's all 0 because we haven't done anything yet. Alright, so let's step through and notice its pointer variable 1 is now contains 0b. Why 0b? And at 0b is the location in memory, data memory, and in 0b, as we know, we have 0305. Now, let me just zoom in back to the assembly code. As mentioned a few moments ago, a pointer variable 1 is allocated 3 locations, and one of the locations is 08. But look at what is the contents of location 08 is 0b, which is actually a reference to this location, the starting location of data 1, which is basically containing 03 and 05. Alright, so hope that's not too complicated. So that's why we have seen here alright, so this is the starting location of pointer variable 1, and as we know, the location 0b contains 0305. This is remember, that's what it's in from 0b and 0c. 0c is not displayed here. What is displayed here is just the starting location of pointer variable 1. All right. Okay, so let's. I think that's about it, really. All right, so this is how the memory location is allocated to the variables. Okay, now that we know how the pointers are being set up and how it works, let's look at how we can get access to the data of a variable using pointers. Basically, I'm going to use the same demonstration code with the addition of this line of code here. So let's move over to the demonstration code. Okay, let's look at the demonstration code. So line 5, line 7, line 9, they are the same as the previous demonstration. Line 11 is the new line of code that we inserted. So let's proceed to the debug session, as I have already compiled the code, so I have 0 errors, 0 warnings. So debug. Okay, so I've at the bottom right here, I have set up the watch window to monitor pointer variable 1 and data 1. up here I have the parallel port 0 ready, and then back down here at the right hand corner I've also set up the memory watch. Right, so and let's take a look at the disassembly code. And so let me zoom in here. Right, so for data 1, the compiler has set aside location 08 and 09 for the address, and in location 08 is 03, and location 9 we have 05. That is correct because that's what we assigned to data 1. Okay, so now let's zoom out, and for the next line of code, okay, let me zoom in here. For pointer variable 1, assign with address data 1. If you take a look at the disassembly version of this time the compiler has assigned 3 register instead of 3 memory location, register R1, register R2, register R3 to pointer variable 1 to store the address of data 1. Remember data 1 here, up here, the compiler has allocated 08 and 09 for the address of data 1. So here the compiler has assigned 3 register for pointer variable 1 to store the address of data 1. Remember, for a pointer variable in the CalC compiler, it allocates 3 locations for the pointer variable. Right. And then, right. Okay. And P0, port 0, assign pointer variable 1 with the asterisk in front. And the disassembly version is port 0. Let me zoom in. Remember, port 0 has a address of 80. Now, so this instruction here, the MOV instruction, will copy the contents of A to the location or to port 0. Alright, that's how it works in this one. So let me zoom out and let us walk through the code. So line 7, so we assign 0305 hexa to data 1. So we watch this watch window here, bottom right hand corner. So step it through and let me zoom in, and we have data 1 that contains 0305 hexa. Now on the next line, we should see 08 assigned to pointer variable 1 because we know from the disassembly code that's what it's compiled to do. So let me just step through. Yeah, and we have let me zoom in. Pointer variable 1 has the address of 08, and then remember at location 08 we have 0305. Okay, so let's check out location 08 in the memory and zoom in here. Sorry about that. Okay, all right. Okay, so 0, 8. We have 0, 3, and 0, 5. Now we come to this line of code. What's going to happen is pointer variable 1 is pointing to location 0, 8 because that's what is being assigned now. And so when this line is executed, it will get to the address 0, 8 and display 0, 5 onto port 0. So watch out for port 0 here. And we got 0, 5. Now the 0, 3 has been ignored. Remember, P0 is an 8-bit register. However, the code here where we have data 1, which was declared as an int, is a 16-bit data type. Now, port 0 is only capable of handling 8-bit. Hence, only 0, 5 is displayed on port 0. So this is how we access the data 1 using pointer. Okay, so I would like to just summarize what just happened with the demonstration code. So here is a block diagram representation of the data memory. And with this instruction here, int data1 assign 0305 hexa, the compiler has assigned or allocate location 08 and 09 for data 1. And this instruction itself would assign 0305 to data 1. So, 03, the upper byte goes to 08, and then 05 goes to location 09. Now, when we come to this part, this is going to be different from the first demonstration. Pointer variable 1 here is assigned with the address of data 1. And pointer variable 1 has been allocated. This time it's been allocated 3 registers. That is R1, R2, and R3 to store the address of data 1. Now, again, just a quick reminder, the compiler automatically is designed to allocate 3 bytes of memory location to the pointer variable. So what that means here is the address of data 1 is stored in these 3 registers, and basically the registers are pointing to the contents of the registers are pointing to the address of data 1. Again, a reminder, only the one of the byte of the address is used in the pointer variable, and that points to this. And in that location, in those locations 08 and 09, we find 03 and 05, which we highlighted earlier. And then with this instruction, the byte 05 is then sent to port 0, P0. All right, so that's how this using pointer to access the data stored in data 1. Okay, so we have to ask the question now, so why do we need to use pointers? It seems rather complicated to a way of getting access to the data that we want. So why use pointers? Now, in order to answer that question, let's recap from the earlier example from my video on functions, and I repeated one of the example here. Here I've declared the function that I want to use is int shift bit with the parameter int input value, and this is the main function. And here we define the function, and the function will perform the action that is required, and then it returns a value back to the main program by using the return statement here. Now, the limitation of return is that it can only return one value back to the calling function. Now, in this example, the calling function happens to be the main. So just bear in mind, return can only return one value. So how do we return multiple values in C? And that's where pointers comes in. Okay, so returning more than one value. Let's move straight over to the Kyle IDE for the code demonstration. Okay, so we are here in the Kyle IDE, and we have the code loaded up here. I have also assembled it, so we have 0 errors, 0 warnings, so we are ready. We're good to go for debug. So we start debug session here, start stop. I've also set up the watch window. Quick reminder, you can do the watch setup by going to view, and then go down to watch window. I'm using watch 1, and it's here. And in the watch window, you enter the expression. So they are all ready here. I also called up the P0 or parallel port 0 and parallel port 1, P1, because we're using it here, P0, P1, P0, P1. And okay, we're good to go. So I'm using F11 to single step. So watch out for data 1 and data 2. So we have 05, 08, because that's what we asked the code to do. So you go 05, 08, and then here we say output or assign data 1 to P0, so we should see 05 here. We do, so 05 in binary, and we should see 08 here when we finish with this data 2 assigned to P1. So yeah, we got 08 in binary. Now we're going to step into the function now. So we have first value, second value. So let me execute it. So now we have the address 08 hexa as that is the address of first value, and second value address is 0A hexa. Now in each of this, at 08, location 08, we have 005 because we have passed it from here to here, so that data 1, the contents of data 1 is passed into the contents of first, which the contents or location is 08, so it has 05. Hope that's clear. And then we have data 2, which is 08. Then now that is being passed into the location store its second value, and the location is 0A, and the contents is 08. So we are good. Now here we're going to assign the contents of first value. What is the address of first value? 08. Assign that value 05, which is stored in 08, to buffer. So watch buffer here, yeah, at 0.5, because we say copy this value to buffer, and then copy the contents of location store at second value. What is the location of second value? That location is, or the address is 0A. What's in 0A? What is in location 0A hexa is 08 hexa. So take that, copy that to the address store at first value. What's the address of first value? 08. So copy the contents of 0A to 08. So we should see, yeah, 08 here and 08 here. And then the buffer, which is 05, the contents of the buffer is 05. Copy that to the address stored at second value. What's the address of second value? 08. So watch out for this part here. That's 505 hexa. So now we return back to the main function. Now we would have 08 going out to port 0, and then 05 going out to port 1. So basically we did a swap using the pointer. So this function here is returning two values to the main function. I hope that is clear. Okay, that's it for this video. It's been a long video, and it has been a challenge for me to produce this video. I think the concept of pointers is not easy to explain. I hope you find it useful. Let me know in the comments below. And as usual, I have included the source code that I've used in the link in the description below. Okay, thank you very much for watching. See you in the next video. Thank you. Bye.